Okay, to get started tinning the little round ring, I'm going to start off with setting it up. And what I like to use is a piece of tungsten. This is a tungsten electrode from a TIG welder. And I'm going to put that tungsten in the vise right here to hold it. Just tight enough to hold the tungsten in place. And we're going to take the ring and I'm going to set it on the tungsten. That's going to hold it there while I do the heating and the soldering process. Now you're going to need the Comet flux. This is available at Brownells. You need the Comet flux and you need high force 44 silver solder. And you're also going to need 2 old screwdrivers. Now I have dedicated these 2 screwdrivers to doing this job, and the rubber on these handles gets soft, and I taped this one up so that I could keep using it. I guess the chemicals in the shop, oil or maybe the Comet flux or something, gets on this rubber and it melts it, so then it sticks to your fingers. And I just taped this handle up on this one. This one here is a little bit sticky, but I think I can get by with it today. So get you 2 old cheap screwdrivers and dedicate them. You can tell these has been heated up and used a lot. They got some solder on them. They got some black burn and whatever. They're not going to get so hot that it burns out the plastic handle. If you're getting it that hot, you're doing something wrong. So these are just basically to hold the ring in place and to scratch it a little bit, or to clean it. I guess I should use that term as cleaning it. You could use a wire bristle brush, but I don't like using wire brushes because then the solder gets stuck in your bristles and your wire brush is scrap and garbage and you can't use it again. So first thing we're going to do is start out by heating up the ring. So I'm going to heat it up. With a little Bernzomatic torch, and I use these little Coleman propane tanks. Most of the time they've got a plastic piece on the bottom and they'll sit flat on your workbench, but this one for some reason didn't come with a plastic piece. So I don't know if they quit making them that way or if this one was missing. But this is what we're going to use. Bernzomatic propane torch. You're going to get that hot until it starts to turn colors. Then we're just going to drip some of this flux on there, and you don't want to just let it hit real fast, because if you do, it just bounces off and you're wasting your material. So you want it to just get on there and sizzle. There's a happy medium. Too hot, it won't work. Not hot enough, and it won't work. So then I'm going to use that screwdriver to roll this over because it's pretty hot. I'm going to put a little more flux on here. There you go. That's the perfect temperature right there. Keep it hot. Now you're going to run this torch on there until the flux turns really black and ashy looking. So we're going to get it hot. Okay, now we're going to try to start melting this solder on here and see if it'll stick. Now you can tell that that's not wanting to stick. See how it's just balling up? We've either got it too hot or it's not clean enough. Okay, so now we're going to try it again, and I can see where I've got a little bit sticking right there. Now it's sticking, so it's not balling up anymore. But what we got to do is put a little bit of solder on the top. We're going to heat it up. We're going to put some more flux on here. We're going to heat that up until the solder is melted. And then you got to use both of your screwdrivers. And this is what I mean by using this screwdriver to clean or to agitate. And you just got to scratch it around back and forth. And your screwdrivers, you got to remember, they're cold. So as soon as they touch, the solder is going to start getting hard. So we're going to put another little drop here. We're going to heat that up again. And you can see that the solder is now fluid again. Just got to keep it hot. And keep working these screwdrivers together, working back and forth. And once you get everything right, this solder will stick all the way around. I still got one little spot right there that it don't want to stick on. So once we put the flux on, it's going to cool it down. Got to heat it back up. We're going to scratch that little spot there for a minute. We're going to go all the way around it and make sure that it's all heated up and it's shiny all the way around. Okay, I believe that that's got it, but we're going to double check it, look at it all the way around. Now the black coating on the top is going to stay there. You can't get rid of it. If you get rid of the black coating, then the flux doesn't work. I actually believe that it has to be black and oily, kind of like what it is, in order to work at all. I'm going to zoom you in there and try to get you close enough to see that. Okay, I think you can see that now pretty good. I don't need to heat it up again. I'm just going to do that for you guys to see it. And you can see this black film on the top. And underneath the black film, you have a nice shiny layer of silver solder all the way around. So I know that that ring is perfectly tinned. It's got solder all the way around it. Now we're going to jump back over here to the lathe and we're going to tin that bolt face and the surface where this is going to meet up and match into the bolt. So let's move on back over to the lathe and I'll show you how we're going to do that one. Okay fellas, we're back over here now at the lathe and we're ready to start tinning this surface right here. So what we want to do is we want to tin this whole surface in here and get solder to stick to that. And it's going to react the same way that that little ring did when we first try to start soldering on it. The solder just doesn't want to stick. It's like trying to solder a copper pipe without fluxing it first. It won't work. So first thing we're going to do is heat that up. We're going to use the same torch. And you got to remember that this little ring out here is really thin, so it's going to get hot a whole lot faster than the bolt head. But you have to heat the whole thing up or else it won't hold the heat very long. You'll lose all your heat out here on the ring and you're just kind of fighting yourself. So you just heat the whole thing up nice and slow. Okay, I can see it starting to change colors, so I know it's getting pretty hot. We're going to put some of our flux in here. A little squirt. Going to heat it up again. We got to get that black oil on there. Okay, it's starting to get black, which is what we want. A little more heat. And now we're going to put some solder in there and see if it'll melt. If we're not hot enough, it won't melt. So there's enough solder to do the job. We're going to use the same screwdriver as a cleaner. We're going to scratch that around in there until that solder sticks to that surface. If you're not happy with the way it's flowing out, put a little more flux on it. Now that's flowing out really good there. You got to remember, you got to keep your heat. Got to keep the heat right. Okay, we've got it flowed out good there. Okay, that is perfect. I'm going to zoom you in there so that you can see it. But you can see we've got a good ring of solder all the way around the surface there that is going to make the joint. Alright, I'm going to sit back up here where we were. We're ready now to put the ring into the bolt. So it's set over there long enough. The ring is cooled off. You can handle it now with your hands. And we're just going to simply stick it in here so that it'll stay right there. I'm going to take a hammer, and I'm not going to beat on it, I'm just going to use the hammer head to push against. And when it gets hot enough, it'll fall right in. Just like it did there. Now, just going to clean it off a little bit. And I like to put an extra little drop or two of solder on there just to make sure that I've got enough. You got to get it hot enough to melt the solder again, and you can see it sucking in there like if you were doing a copper pipe, and that's going to be plenty. Okay, and that is soldered in there. It's not going to move. It will never come out. I'm going to use this hammer to push on it just to make sure that it's all the way in, and it is. And the hole that's in the bolt itself, the little rivet hole, you want that facing down so that the solder will fill that hole up, and once you clean it off, it'll look nice. So I'm going to take this hammer and I'm going to put that against that ring, and I'm going to put enough water on it to freeze the solder. Alright, and then I'm going to let the rest of it pretty much cool off by itself. I want to rinse off this flux on my machine here. That flux will cause an erosion to your carriage top. Any of your bare metal is it's going to show a mark, kind of like rust, but not really rust. So what I'm going to do is, while this is cooling down, I'll turn my coolant on And I'll just let that coolant run across there so that I won't get any rust, and put another coat of oil on all my surfaces. The coolant that I use in my machine is called Trim 206. E206 is the coolant that I use on this machine. It leaves a nice oily film when you walk away from the machine. If you're going to go away from it for the weekend, or some of you guys may not have climate controlled shop and it sweats, and you come back 3 days later and you've got rust all over your machine. So you want to use an oil-based coolant so that when the water dries out of it, there's a layer of oil on all your bare metal. And another little thing I'll tell you is, don't clean your machine all the time. If you clean off your ways and you clean everything up, you come back, it's rusted because you took all the oil that was on it off. So we're going to let that cool down, and then I'm going to get back to you guys here in just a minute when we get ready to do the rest of the machine work. Okay, so we're back now to the bolt here, and we're going to machine the metal ring that we put in there. And if you remember, I told you you wanted this hole to be on the downside when your solder dries, and then that hole gets completely filled with solder. Turns out real nice, and once you machine that off, it's just nice and round and looks good. So we're going to come in and we're going to start doing the machining. Now this is a standard bolt face for a 308, 30-06, 22-250, that kind of stuff. So the standard bolt face should be about 480. So we're going to machine that out to 480 thousandths, check the fit, and see how it's going to work. And what I do is I use just an old spent 308 cartridge case. We want that to fit in there, and you want to be able to work it side to side without it hitting on anything, without it grabbing. If you try to machine it too tight, and I've seen a lot of guys do this, they think tighter is better, but it's not. You got to have enough room in there for stuff to move around and center itself up in the chamber. Actually, if you were actually doing this for a center fire, this is for a muzzle loader, so it's not that critical. But on a center fire, you got to have enough room in there so that the cartridge can find center in the chamber. It doesn't really necessarily matter where center is in the bolt face. It's got to be close. But your most important is to be center in the chamber. So we're going to come in there with this same boring bar. We haven't changed anything. We haven't even taken the boring bar off of the tool post. That's an important thing. Don't even take it off, because if you lose the measurement from where you started, then you got to try to find the measurement again, and it's harder to do the second time around. So we're going to bore this out. We're going to take it to the same zero that we used when we bored that pocket in the bolt. So we know where our bolt face is at and where the cartridge case is going to sit up against. So we're going to start by machining the face of that off. And I'm going to use a boring bar for all of the machining on this. Okay, so the first thing I've done is I've machined off the face of that ring flush with the original face of the bolt. And when you get there, that's where you're going to stop at. And there's no right or wrong measurement. They all fluctuate a little bit. But as long as you get close to where you were at when you started, you're good enough. Now we're going to start machining out the pocket. And again, you want to remember to go real slow, take small cuts. You can always make an extra pass, but if you take it off, you can't put it back in there. So we're going to take a measurement, see where we're at. We're at 460. So we need 10 thousandths off the diameter. So I'm going to set a 0, I'm going to go 10. That's going to take 20 thousandths off of the whole thing because we're taking 10 off each side. I'll check the diameter again with the micrometers, see what we get. And I've got exactly 480 and a half. So we're in pretty good shape right there. Now we're going to take this cartridge case and stick it in here and see that we've got nothing hanging. There's no binding at all there. So that's perfect. Without setting anything on without changing my X dimension, I'm just going to come in at my Z, touch my 0, and then I'm going to roll across the face of my X. Okay, so we got that done. Now I'm going to chamfer the edge. I'm going to put a 45-degree chamfer on here. And if I had to guess, I'm going to say that's about a 50 thousandths chamfer. So I don't know if you guys can see that little chamfer that I put on there. It's not a lot, it's just enough to break the edge. Then I'm going to put on my standard turning tool that I use all the time. I'm going to come in here and I'm just going to touch the outside diameter of this recessed bolt nose, and we're going to skim off this drop of solder. Okay, so that looks pretty good. We didn't quite clean up the whole bolt nose, and I'm not going to try to clean up the whole bolt nose. I'm going to leave it just like it is. We're not off by much, but I want to leave it as close to the factory shape as I can. The only thing I will do is I'm going to take a little file and slow my machine down, and I'm going to file a little chamfer on this leading edge. Okay, so now that's done. I'm going to take the same file, and you can see there's just a little bit of solder right there that didn't clean off. I'm going to knock that away with this little fine tooth file. Okay, so now that that's done, that's all the machining that we have to do in the lathe for the Sako extractor to work. And you can see what I'm talking about by when I push this shell in, I can bend it down and it don't catch on anything. I can bend it up, it don't catch. It doesn't catch anywhere. You got to remember that, because when you want to throw your shell out, when the ejector pushes on it, you don't want it binding up over here in the corner because you made your diameter too small. Then it gets stuck and that causes ejection problems. So we've got that all fixed. We're going to take the bolt out of this fixture, and then it'll be ready to move over to the milling machine. So we're going to start by loosening all 4 of these bolts. Rotate the locking blocks or tabs over. We take the bolt out. I'm going to put the screws back in the fixture. And the fixture is now ready to come out of the lathe, but I'm not even going to worry about doing that right now. I'm going to take you guys straight on over to the milling machine where you can see it's finished putting in the extractor. So here's what it looks like after it's been machined and the ring has been put in. So let's go on down to the milling machine and we'll get set up on that job.